Alright, hey everyone, it's Server, and so I got this math problem for homework for school today, and I had a lot of trouble with it, so I thought it would be interesting to share with my 7 viewers. I love you guys. So basically they give us this figure right here. It's a pentagon with a ton of lines through it, and they give us these 3 given statements. AD is congruent to BD, so whoops, that's wrong. Let me highlight these as we go. AD is, oh no, AD right here, and I'm trying this with a mic for the first time, so I'm not sure how I'll sound. Hopefully I don't sound too stupid. AD is congruent to BD. There we have it in red. Then there's also AE. Oh, whoops. Then AE. Sorry. Yeah, I really need to get better with this program. Stop right now. Okay. Press that, and press that button. Alright, AE is congruent to BC. That's wrong again. As you can see, I'm not very good at this just yet. AE is congruent to BC. And CD is congruent to ED. So I've sort of color-coded this so you guys can tell the difference, / what is congruent. Alright, so we learned that when two opposite sides of a triangle are congruent, they are obviously isosceles. Okay. Turn that orange. This line should be orange, not red. Alright, so when two sides of a triangle are congruent, it's an isosceles triangle, and the angles opposite to those sides are also congruent. So that means these two angles right here, angle DAB and angle DBA, are congruent. That's how we're going to show that. Alright, we can also say that these two triangles, I will try to shade it in yellow, because yellow isn't that distinctive. These two triangles right here are congruent because of side, 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 which means basically that all 3 of their sides are congruent. With side, side, side on these 3 givens. So after we say that, we can use CP/CTC, or congruent parts, corresponding parts of congruent triangles are congruent, to say that these 2 angles, I'll use green, these 2 angles, angle EAB, angle EAD, right here, and angle CBD are congruent. So we just said angle EAD is congruent to angle CBD. And then after we say that, we can use the addition property to say, well, the addition property basically states that congruent angles plus congruent angles are equal to a congruent angle. So we can say that angle DBA, DBA plus angle, actually let me switch colors back to that green, DBA, which is right here, plus angle CBD is equal to angle, this angle right here, DAB. DAB probably should have left some more oh, never mind, we do have more space. Plus angle EAD. So if we use the addition property to say Basically, that's saying that this huge overall angle right here is congruent to this overall angle right here. So angle, angle EAB is congruent. By the way, this is the same thing as this. Is congruent to angle CBA. So once we've said that, we'll try to prove. Okay, that's not scrolling. We'll try to prove these two. Let me make this one. We're going to try to prove these two triangles right here congruent. That one and that one. Going to try to prove those two congruent. Because if we can prove these two congruent, we know that this little angle right here, it's in pink, is congruent to this little angle right here. And if we know that, we can say that these two sides, AF and FB, are congruent, which proves that triangle FAB is an isosceles triangle, which is what we're trying to prove. So after we have that angle EAB is congruent to angle CBA, we can say that we can say that AB is congruent to itself. So let me use purple for that one. We can say AB is congruent to itself because of the reflexive property. And once we have that, we can say that, sorry, hold on one second here. Triangle ABC, so this triangle right here, the one we did in blue, all over here, is congruent to triangle ABE because of side, angle, side. And our sides, angles, and sides are this overlapping triangle. AB is congruent to AB. Our second given, I believe, yes, second given, AE is congruent to BC. And our angle is this huge overlapping angle right here. So side, angle, side. And that huge overlapping angle, once again, is EAB. Is congruent to CBA, which we said right over here. If you guys want to visit that again, to make sure you have that down. Alright, so now that we've proven these two triangles, triangle EAB and triangle CBA congruent, we can use CPCTC to say that these two angles, that's angle FBA, let me write that down, angle FBA is congruent to angle FAB. So once again, those are these two angles right up here. We can prove that those are congruent. Remember CPCTC. And using that, we can say that. Well, Miss Fenvesh says we can call it isosceles, so that's what I'll call it. Because of isosceles, FA right here is congruent to FB. So FA, line segment FA, is congruent to FB because of isosceles. I'll probably spell this wrong, but it's not a real word anyway, so that does not matter. And then once you have that down, you can simply say that triangle FAB is isosceles because of the definition of isosceles. So if this isn't right, because I know she stressed that this proof is really wrong, and if you find a mistake here somewhere, please point it out so all of us don't end up getting this wrong. Okay. Have a nice day. Sure, have a nice day.